Hey everyone, and welcome back for another deep dive. Today we're going to be talking about quantum computing, a topic I'm sure a lot of you are very interested in.
Absolutely.
There's been a pretty remarkable development, and I thought we'd take a deep dive into this new research paper.
Yeah.
It's called New Photon Entanglement Breakthrough Could Miniaturize Quantum Computers.
Catchy title.
Yeah, and you know what? It definitely lives up to the hype.
It does.
So it was published by SBI, the International Society for Optics and Photonics,
Okay.
just earlier this month, actually, March 8th, 2025, so it's hot off the presses. And
Very new.
the core of this research really focuses on overcoming a significant hurdle in quantum computing, and that is...
Photon entanglement.
Right, entanglement. It always sounds so futuristic to me.
It really does, almost like science fiction, but it's very, very real.
And so for those of us who maybe aren't, quantum physicists,
Sure.
can you explain what photon entanglement is in a way that, we can all wrap our heads around?
Absolutely. So imagine you have two photons. These are tiny little particles of light, and they're linked together
Okay.
in a way that no matter how far apart they are, they share the same fate.
Okay.
If you change the state of one of those photons, the other one instantly mirrors that change.
Wow.
It's almost as if they're communicating faster than the speed of light.
That is wild. So how does this entanglement actually relate to making quantum computers work?
Great question. So, regular computers that we use every day, those rely on bits,
Right.
which can be a 0 or a 1, but quantum computers use qubits.
Qubits.
And qubits can be 0, 1, or both at the same time because of this principle called superposition.
Both at the same time. That's crazy.
It's mind-boggling, and entanglement is what allows these qubits to interact with each other
Okay.
and to work together to create a whole new level of computational power.
So the more entangled photons you have, basically,
Yeah.
the more powerful a quantum computer can be.
Essentially, yes.
Okay, so the article mentioned that creating and managing these entangled photons has been like a major obstacle.
It has. It's been one of the biggest challenges in the field, and there are two main methods that have been used traditionally.
Okay.
One involves quantum nonlinear optical processes, and these are incredibly complex and very difficult to scale up.
Okay.
The second method that's been used involves linear beam splitting and quantum interference.
But that's going to have some drawbacks too, right?
You're exactly right. This second method requires these incredibly complex setups that are very sensitive,
Oh, I see.
and they're prone to signal loss. And so both of these approaches have been major roadblocks to creating smaller,
Okay.
more practical quantum computers.
And that brings us to the exciting part of this new research because they've found a way to get around those obstacles, right?
They have researchers from Peking University and other institutions in China have developed this new method for generating entangled photons. And they're doing this using something called metasurfaces.
Okay, metasurfaces.
Metasurfaces.
What are those?
So imagine a sheet of material that's thinner than a human hair.
Wow.
And it has these meticulously engineered structures on its surface.
Hmm.
And these structures, they act as this kind of optical filter, allowing us to control light in really precise ways.
Okay.
We can manipulate its phase, its frequency, and its polarization.
So instead of needing those huge, complicated setups you were talking about,
Yeah.
you can now create entangled photons on something like super tidy.
That's exactly it. It's a game changer.
Wow.
These metasurfaces really simplify the whole process of generating and manipulating those entangled photons.
Okay.
It's far more efficient, and it's incredibly compact. Think of it like this. You're trying to navigate a really complicated maze,
Okay.
and suddenly you discover this shortcut that takes you directly to your destination.
So you've got a shortcut now.
We do.
That's amazing. So this all sounds really promising, but what does it actually mean for the future of quantum computing?
What?
I mean, are we going to have quantum computers in our pockets anytime soon?
Maybe not in our pockets just yet, but this breakthrough, it really opens up the possibility of creating quantum devices that are small enough to fit on a chip.
On a chip. Wow, that is crazy. So what would that actually look like? I mean, can you give me an example?
Imagine a world where quantum computers are as commonplace as laptops.
Okay.
They're no longer these massive machines confined to research labs. They're accessible to businesses, to hospitals, to individuals.
So this could really democratize access to this kind of technology.
Yeah, it could revolutionize so many aspects of our lives.
Wow. The article also mentioned something about quantum networks. So how do these metasurfaces play into that?
That's another really exciting avenue this technology could be used to create networks that can transmit those entangled photons
Okay.
across really long distances.
So you could essentially have a communication network that's virtually unhackable.
That's the idea. It's based on the principles of quantum mechanics.
That's incredible. Professor Yinggu, who's one of the lead researchers on this project, described this new approach as a fresh perspective for quantum information processing.
It's a great way to put it.
And I think that really sums it up well.
It does.
We're basically finding solutions to problems that previously seemed impossible.
Absolutely. It's a paradigm shift in how we think about quantum computing.
It's amazing to think that something so tiny, something so seemingly insignificant, could have such a profound impact on our world. But I'm also wondering, are there any potential downsides to this miniaturization?
That's a great question, and it's one we should definitely consider.
Yeah.
While the benefits are huge, we need to approach any new technology with a balanced perspective.
Of course.
We have to think about the ethical implications, the societal impacts, and make sure we're using this technology responsibly.
That makes a lot of sense. It feels like we're on the verge of something truly revolutionary.
We are.
But we need to proceed with caution and excitement.
Absolutely.
Yeah.
It's a delicate balance.
Yeah.
But the potential is truly remarkable.
Well, this research has definitely opened a door to a whole new world of possibilities. So what exactly does this mean for the average person? How will these advancements actually impact our everyday lives?
That's a fantastic question, and one that I think we need to explore further. This breakthrough has implications that go way beyond faster computers.
Okay.
It could potentially touch every aspect of our lives.
Wow.
From healthcare and energy to communication and transportation.
Well, let's dive into those possibilities and explore the true impact of this quantum leap forward.
Let's do it.
We'll be right back after a quick word from our sponsor. Okay, so we're back and ready to dive into just how these miniaturized quantum computers could impact our everyday lives.
Exciting stuff.
It really is. It's one thing to talk about chips and, theoretical networks, but how will this technology actually change things for people like you and me?
Well, let's start with a field that I think touches everyone's lives, healthcare. Imagine a world where doctors can use quantum computers to simulate, incredibly complex biological processes. This could lead to personalized medicine that's tailored to your specific genetic makeup, paving the way for treatments and cures that are currently beyond our reach.
That's incredible, but those simulations you're talking about, those require massive amount of computing power, right?
They do.
The kind that only huge research labs can handle.
Right.
So wouldn't that limit access to this technology?
That's where the miniaturization aspect becomes really game-changing.
Okay.
If we can shrink these quantum computers down to a size that's accessible to hospitals and clinics, it really democratizes access to this cutting-edge technology.
I see.
Imagine a world where personalized genetic analysis and treatment plans become standard practice.
So you're saying that a routine checkup could involve analyzing your entire genome?
Exactly. Leading to early disease detection and personalized preventive measures.
It's amazing to think that something like that could become so commonplace.
It really is. And the potential goes far beyond just healthcare.
Okay.
Let's consider material science for a moment.
All right.
Quantum computers could allow us to design and create entirely new materials with properties we haven't even dreamt of yet.
Like what?
Imagine super strong, lightweight materials for building everything from skyscrapers to spacecraft.
Wow.
Or materials that can conduct electricity with zero resistance.
Wow.
Leading to hyper-efficient energy grids.
It sounds like we're talking about a future with self-healing buildings, flying cars, and virtually limitless clean energy.
It's all within the realm of possibility.
It's hard to even grasp how quickly we could see these advancements.
I know, it's mind-boggling.
With widespread access to quantum computing.
The potential for accelerated discovery is truly immense.
So let's shift gears for a second and talk about another exciting application, artificial intelligence.
Yes, AI. This is a huge one.
The article touched on that as well.
It did.
What kind of impact could these miniaturized quantum computers have on AI?
Well, quantum computers could empower AI systems to learn and adapt at an unprecedented rate.
Okay.
Leading to breakthroughs in fields like self-driving cars and robotics.
So we could have robots working seamlessly alongside humans, performing complex tasks and solving problems that require advanced reasoning and learning abilities.
That's the idea.
It's fascinating, but it also makes me wonder about the potential downsides of such rapid advancements in AI.
Sure.
Will we be able to keep up ethically and socially with the changes brought on by this technology?
That's a really important point. It's essential to have open and honest conversations about the ethical and societal implications of these technologies.
Yeah.
The potential for job displacement, the need for new regulatory frameworks, and even the possibility of misuse.
Right.
Those are all crucial considerations.
We need to approach this new era with a balanced perspective, right?
Absolutely. Embracing the possibilities while being mindful of the potential challenges.
So it's not just about the technology itself, but how we choose to use it.
Exactly. Technology is a tool, and ultimately, its impact depends on us.
That's a good point. One of the challenges that comes to mind is ensuring that the benefits of quantum computing are accessible to everyone.
Yes, absolutely.
Not just a select few.
Equity is crucial. We need to address issues like affordability and the potential impact on the environment.
Right. Sustainability shouldn't be an afterthought.
It should be a top priority.
It's clear that this conversation goes far beyond just the technical aspects of quantum computing.
It does.
We're talking about shaping the future we want to live in.
Exactly.
A future where technology empowers us to solve global challenges and create a more just and sustainable world.
I completely agree. And I think it's important to remember that we have a responsibility to guide its development and make sure it serves the best interests of humanity.
So as we stand on the brink of this quantum revolution, it's not just about building faster computers or more efficient networks.
Yeah.
It's about understanding the profound implications.
Yeah. And making conscious choices that shape the future we want to create. This is about more than just speed. It is about potential and progress.
Absolutely.
But beyond these kind of obvious fields like medicine and AI, are there other, perhaps less obvious applications where this technology could make a significant impact?
Absolutely. There are so many areas where miniaturized quantum computers and these innovative metasurfaces could lead to breakthroughs.
It's time to think outside the box.
It is beyond the expected.
Well, let's delve into those less obvious but equally fascinating applications when we return for the final part of our deep dive. Okay, so we're back and ready to explore some of those less obvious applications of this breakthrough. We've talked about healthcare materials, science, AI, but where else could these miniaturized quantum computers make a real difference? What about the fields that don't immediately come to mind when you think quantum?
Well, that's what I find so fascinating about this discovery. It really has the potential to revolutionize areas we might not typically associate with quantum computing.
Like environmental monitoring and climate science, for example.
Okay, that's not what I would thought of right away. How could these tiny quantum computers contribute to those fields?
Well, imagine swarms of these tiny interconnected quantum sensors.
Okay.
Powered by these chips, constantly monitoring the environment.
Okay.
We could be collecting real-time data on air and water quality, soil conditions, even seismic activity, all with incredible precision and on a scale we've never seen before.
So we're talking about like a quantum leap in our ability to understand and respond to environmental challenges.
Exactly. This could revolutionize our understanding of climate change, pollution, natural disasters. We could develop much more effective mitigation strategies, predict and prepare for extreme weather events, and even monitor the health of ecosystems in unprecedented detail.
That's huge. It seems like the possibilities are pretty much endless. What other surprises do you have for us?
Well, let's venture into the realm of space exploration.
Okay, space.
Imagine compact, powerful quantum computers onboard spacecraft, capable of handling immense amounts of data in real time. This could revolutionize navigation communication. And even our ability to analyze data from distant planets and moons.
So we could have probes with these miniaturized quantum brains making decisions on the fly, analyzing data, transmitting findings back to Earth. Almost instantaneously. It'd be like having a team of scientists on a distant planet, but without the limitations of time and distance.
Precisely. It opens up a whole new frontier in our exploration of the cosmos. We could study distant stars, galaxies, and planetary systems in ways we can only dream of today.
This is also incredibly fascinating, but it also makes you wonder, what are the limits? What can't these metasurface-powered quantum computers do?
That's the beauty of scientific discovery. It's impossible to predict the full scope of its impact. We're really just beginning to scratch the surface of what's possible, and that's why this new era of quantum computing is so exciting.
It really does feel like we're on the cusp of something truly extraordinary. But before we wrap up, I have to ask, what does this all mean for our listeners? Why should they care about these seemingly futuristic advancements?
Well, this isn't just about science fiction or abstract theories. This is about real-world solutions to some of the biggest challenges facing humanity, whether it's developing life-saving medical treatments, combating climate change, or exploring the vastness of space. These advancements have the potential to impact every aspect of our lives.
So this isn't just about scientists and labs. It's about the future we're all building together.
Exactly. And that's where our listeners come. And the future of quantum computing isn't predetermined. It's being shaped right now by the choices we make, the questions we ask, and the problems we choose to solve.
So what applications can you envision? What impact do you want to see in the world? That's something to ponder as we wrap up this deep dive into the incredible world of miniaturized quantum computers. Thanks for joining us, and until next time, keep exploring, keep learning, and keep pushing the boundaries of what's possible.